Okay, welcome back to Precalculus. We are talking about hyperbolas today. This hyperbola is not given to us in the regular form. Okay, so we have to do a little bit of surgery on this before we start, but it's not going to be too bad. Yeah, all we have to do really is divide by 4, because remember, one of the important things is that the right-hand side is equal to 1. Okay, so all I'm going to do is go ahead and divide by 4. So we have a negative x squared. Where's my little pen here? Right there. All right, now pause. Okay, so we have our negative x squared, and we have our y squared, or y squared equals 4. So the first job, divide everybody by 4. Okay, so we're going to end up with a negative x squared over 4 plus y squared. I'm just going to say over 1 because we're going to need that 1 eventually, is equal to 1. We just divided everybody by 4. By 4. Okay, now I know that my transverse axis is going to be in the y direction. I didn't see the name for like the axis in the negative direction. They didn't specify what it was called, so I don't. That's going to be called. I guess I keep going with the ellipse vocabulary and call it the minor axis, but that's not really what it is because it's not really there. Okay, so because the y value is the positive one, we have a hyperbola. It's going to be an up and down orientation. Left and right side is imaginary, so that's not really there. And now when I go to make my little box here, okay, again, we use method of intercepts. So we set x equal to 0, solve for y. Okay, so we just have y squared over 1 equals 1, y squared equals 1, y is equal to plus or minus 1. Okay, that's those are the points of my vertices. Notice that the center is at 0, 0, so we should probably go over that too. Like, how the heck, other than knowing that I'm in section 10.2, how do I know this is hyperbola? And the way I know is that both variables are squared, one of them is negative. Okay, after we get done operating on this thing and putting it back into a form that looks good, one of the values is negative, one of the values is positive, both variables are squared. Okay, that's how I know it's a hyperbola. Okay, so we're going to go ahead and continue with our method of intercepts here. So we're going to set y equals 0. So x had a turn at being 0. Now y gets a turn at being 0. And we're going to solve for x. Okay, knowing full well that we have negative x squared over 4 is equal to 1. So we're going to say, oh, x squared must be negative 4. We know that because x squared, or x is going to equal plus or minus 2i, okay, not I hat, just I. We know that this is not where the vertices are, because this is on an imaginary space. Okay, we're not going to graph this on an xy plane. Okay, but we are going to pretend that we did. Okay, so when I go off to do this one, we have y is positive 1, negative 1, x is positive 2, negative 2. So when I draw my box here, okay, that's how we're going to draw the box. Okay, and why do I need to draw the box? Is because I need to write in the asymptotes here. So we'll go ahead and change my colors. We've got red for this one, and all I'm doing is drawing in. It's going to go through the center. Okay, even if the center was not at 0, 0, it's still go through the center. Right, this box values are going to go through the center. Okay. So yeah, we have our asymptotes. Now, if I want to go ahead and graph this thing, I know that our vertices are x in the y version because the x1 was negative. So that's not going to work. So we're just going to go in and sketch our hyperbola in here. And as with regular curves, we're going to hug our asymptotes and see how close we can get. Okay, and the further away we get, the closer we're going to get to the asymptote. Okay, so let's see. That's what I would do for graphing this thing, right? if I wanted the equation of the asymptotes, okay, this is always a question that students have a little bit of a tougher time with. We're just going to use rise over run, okay? Our b, because we went through the origin, our b is going to be 0, so we're going to say y is equal to, I'm going to cheat a little bit and say plus or minus, okay? What was my rise was 1, right? Our y value was 1, and then our x value was plus or minus 2, okay? So my two asymptotes are the equation, y equals positive half x plus 0, and y equals negative half x plus 0. And those are the two equations for my asymptotes. Okay. If the center was somewhere else, I would have to use a point and a slope. Okay. Y minus y naught equals x minus x naught. I would plug in my rise over run part. Okay. We'd still have that rise over run, but I would have a different point. I would have a center point. And then I'd have to recalculate and get my b that way. Okay, so that's how I would do that. Okay, so let's see how we are in the problem. Okay, so hyperbola, where's the center? Okay, we'll see if we can't get this a little bit better this time around. We're going to go up to, I guess, 1. Okay, there's my vertex. And then we'll try a point on the asymptote. So we are 2, we are 1 up and 2 over. Okay, so we'll give that a shot. And that should be our check. It did not like that at all. Okay, let's double check it. Let's see, y was plus or minus 1, x is plus or minus 2. So let's try this one. So we have our center. Okay, our vertex is going to be 1 up. Okay, I have a hard time seeing that too, I guess. And then we have like that. And to me, that looks the same as what we just did, but yeah, we'll try it again. Still incorrect. Let's see what they actually say. What? What is the difference? So if you're having trouble with these, believe me, I sympathize with you. Okay, I really do. I suspect you're going to have a much easier time with this than I do because your eyesights are probably much better than mine. Okay, so I think we're doing okay as far as the idea of what we're doing, but of course, Alex is going to be very picky about getting that point exactly. Okay, so I'm going to call that good. We're pretty darn close. I can't tell the difference between those two answers, my answer and their answer. So if you're in the same boat, okay, I have a lot of empathy for you. So we'll continue and take a look at the next one, and I will see you in the next video. Thank you.